Good morning, students. Now it is HS second year mathematics class, and we are doing calculus. That is differential calculus. We are going to do, and continuity already finished, chain rule finished, implicit, explicit function finished. Then functions, some functions, that is we are using log to do these things. So that we are going to do. So already we have done some of question up to question number that is in exercise 5.5 up to question number 9 we have done. Now we will do next question. So let's start our question. So as we have seen that in question number 9 up to we have finished. Now question number 10, it is similar way we will do exercise 5.5, and here x to the power x cos x is given. X to the power x cos x plus x square plus 1 by x square minus 1. So let y is equal to this one. So as usual you have to take. So also you will take what? U is equal to x to the power x cos x. It is the rule. Already we have taken this one, and VO you will take as x square plus 1 by x square minus 1. Here you see that it is a variable. Power is in terms of variable. So of course you will do what? Use log. So if you use log here, it will be log U log x to the power x cos x. Power it is, so it will come in log. It is the property of log. Now we will use differentiation. If we differentiate this one, then it is 1 by u du dx. It is the rule. If it is in the term of variable u, if you differentiate with respect to x, then log u it will give 1 by u, and u is again you have to differentiate with respect to x, du dx. Now you will do this one. Here three terms 1, 2, 3. So if you differentiate, cos x log x will remain same. X if you differentiate it will give 1. Now if you differentiate cos x, it will give minus sin x, and log x log x will remain same. Then this one. Here you remember plus it was, but cos x gives minus sin x. With that I have given minus sin. Log x you differentiate, it will give what? 1 by x, and x cos x will remain same. So this is what du dx is u into this term. U is this. So x to the power x cos x, inside bracket this big term cos x log x minus x sin x log x plus cos x. This is our du dx, that is differentiation of this part with respect to x is this. Now here you see that u by v form. So if you differentiate v with respect to x, it will give what? V square in the denominator. Numerator x square minus 1 will remain same, and you have to differentiate the numerator. X square differentiation is twice x, 1 to 0, minus. Now keep numerator as it is, differentiate denominator. If you differentiate this one, it will again give twice x, and minus 1 to it is 0. So we left with what? This term. If we little bit simplify, x square minus 1 root square, here 2x cube. Here if you draw the bracket, 2x cube minus twice x. Here you again see that minus 2x cube. So this term, that term will cancel. Minus 2x and this will give again minus 2x minus 4x is there. So differentiation of this is this part, differentiation of that part is this. Now if we merge these things, that is, here you see that if we write what y as u by u plus d, so dy dx will be what, du dx plus dv dx, it is the rule. So with that we get what, dy dx, it is dv dx plus this term. So this is our question number 10. Now we will go for question number 11. In exercise 5.5 we are now doing, and now we are moving to question number 11. So I expect all are getting this one. So now question number 11, it is now question number 11, it is also of same thing. So I want to give this one as homework. So it is similar way, using u and v you can do. So same type of sum, no need to do. We will now move to question number 12. Question number 12, it is given x to the power x plus y to the power x is equal to 1. And you have to find what, according to them, it is dy by dx, they have said. So here again you have to use the same formula, that if you take this one as u and b as y by x, here variables power variable, here also variables power variable. Of course you have to introduce log. If you introduce log, here x is power, it will come. So I think it is very clear, x to the power x. So power x will come in front and log x you have to write. And here if you use log, here it is x log y, because power it will come in the front. Now if you differentiate, already we have experienced this one, it is 1 by u du dx, because differentiation of log u is 1 by u and du again you have to differentiate. It is product of two terms. So if you keep log x, differentiation of x is 1, no need to write. If you keep x and differentiate log x, it is 1 by x. So it will cancel and we are left with what, du dx as u into this one, u is x to the power x log x plus 1. This is our du dx. Now this if you differentiate, it will be again 1 by v dv dx. Then log y you keep as it is, differentiate x. Differentiate of x with respect to x is the 1. Now keep x as it is. Differentiate log y. Log y, it is not log x. So it is what? Log y differentiation is 1 by y. Then y we have to differentiate, it is dy dx. So we left with what? dv dx as v is y to the power x log y plus x by y dy dx. So see, this is our du dx, this is our dv dx. Now I want to erase something. Here you will find what? This is u plus v is equal to 1. If we put x to the power x as u, y to the power x as v, then u plus v is equal to 1. If we differentiate, it will be what? du dx plus dv dx is equal to 0. Differentiation of u with respect to x, differentiation of v with respect to x, Differentiation of 1 with respect to x, it is 0. Now, this gives what? Our du dx is this, dv dx is this plus this is equal to 0. That is, if we use du dx is equal to minus dv dx. So we can write this dv dx, this one is equal to minus y to the power x, this. Now our target is what? To find the value of dy dx. So we will take dy dx in one side, remaining all thing in one side. If we take this one in one side, it will be this into that x. Y to the power x divided by y gives y to the power x minus 1 dy dx. I have taken this term in that side. Now I will take all this term in one side. Now we will left with what? Minus y by x log y minus x to the power x log x plus 1. So now what will be the dy dx? If you take, first you take minus sign common. If you take minus sign, it will be plus. And if you take below this one, it will be x y to the power x minus 1. So this is our dy dx. So this is a big term, no doubt. Here technique is little different, but you can do this one. So we left to this one what it is, y to the power x log x, x to the power x log x plus 0 divided by, I think it is okay only. If my question is correct, then it is okay only. So I think in my book it is written x to the power x, y to the power x. In some book it is printing mistake here. It is, so far as my knowledge, x to the power y plus y to the power x is equal to 1. If x to the power y, it is similar technique you have to follow. Here it is maybe little printing mistake, but some books I found it is x to the power y. Then you have to do in the similar way. I think you can do what is written in my book, that I have written only. Okay, now question number 13. Question number 13. It is given as y to the power x plus x to the power y. Here students, you see that directly we can use the log. If we use log here, then it will be what? X log y. Because log y to the power x will come in the front, x log y. Here y will come in the front and log x. What we have done? We introduce log in both the side. Now if we differentiate u into v form, it will be x. If we differentiate, it will be 1, log y will remain same. When log y you will differentiate, it is 1 by y dy dx. Then y you keep as it is, log x if we differentiate, it is 1 by x. When y you will differentiate, it is log x dy dx. Now students, it is the rule. If you want to find dy dx, you will take all dy dx in one side, remaining terms in other side. So if we take dy dx common, x by y minus log x. And here y by x minus log y. So of course dy dx it is what? You can take LCM also. If you take LCM, then it is x, it is y minus x log y. If you divide this one and take y LCM, then it is x minus y log x. Now little simplification, x and y if it is go, y inside bracket y minus x log y divided by x minus y log x. So this is our question number 13. So I expect you understood these things. Similar way, similar technique we are applying, and of course you have to go in the similar way. Now question number 12. Question number, 13 finished. 14, similar way we can do. Quickly I will finish this one, cos x to the power y and cos y to the power x. So you understood that this is also similarly we will follow. And what will be these things? If we introduce log y log inside bracket cos x, I will quickly do because I have to finish this exercise, and x log cos y. So this is our thing, that if we take log, give log, then if we differentiate, log cos x will remain same. Y if you differentiate, it is dy dx, because it is u into v form. Now y you keep as it is. Differentiation of log cos x is 1 by cos x. Log will give this one. Cos x if you differentiate, it will give minus sin x. Now this side, x if you differentiate, it is 1, so log cos x cos y will remain same, plus, now x you keep as it is, log of cos y gives 1 by cos y. Cos y differentiation is minus sin y, and then y also you have to differentiate, it is what? Dy dx. So I again want to repeat, u into v form, x if you differentiate, keep this as it is, so x differentiation 1, log cos y remains same. Now if we keep x and differentiate log cos y, log will give what? That 1 by cos y. Cos y we have to differentiate, it will give minus sin y. Then it is y variable. Y you again have to differentiate, it is dy dx. So I think you understood these things. Now take dy dx term in one side. If you take dy dx in this side, then from here log cos x will remain in one side. This term, if you take in this side, actually it is minus. If comes in this way, it will be plus, and you see this is what? Plus x tan y, and log cos y, this term will go this side, it will be minus term, so it will be plus y tan x. So dy dx becomes log cos y plus y tan x divided by log cos x plus x tan y. Student, this is your answer of this question number 13. So I think you understood this one. Now quickly I will follow question number 15 also. So little quickly I will go, and I think you are clear with this one. Still, if you find any doubt, you can ask me. In my personal mobile you can ask. Now question number 15. It is given xy is equal to e to the power x minus y. Here you see that e is a fixed term, a constant term. So e to the power something, no need to take log. You can, if you don't take log, then also you can do. Directly you differentiate both the side. If you differentiate this x into y, it will be y. Y will remain when x you differentiate. dx it is what? 1. So 1 into y. When y will differentiate, it is dy dx. Now this one, if you differentiate this, e to the power x, if you differentiate e to the power x will remain. So e to the power x minus y, that is e to the power x minus y will remain. And what extra you have to do, you have to differentiate x minus y again with respect to x. X you differentiate, it is 1. Y if you differentiate with respect to x, there is no way to write dy dx. Now take all dy dx term in one side. So this term will give x, this into that, this will give what? Plus e to the power x minus y. Because it is the minus term, e to the power x minus y into dy dx, it will come in this side, then taking dy dx, it will give this one. Then e to the power x minus y minus y. So what is dy dx? It is e to the power x minus y minus y, x plus e to the power x minus y. This is our question number 15. So I think yes, you can replace also e to the power x minus y by what? xy. So this term from our given condition, you can write this one as xy minus y. This also you can take e to the power x minus y. From this you can write this. Taking y common, then it is what? X minus 1. Here also x if you take common, 1 plus y, it is y plus 1. So you can simplify like that, but if you are failed to do, no problem. You can get the same things. Now question number 16. Question number 16, they have said that, I will read this question. Find the derivative of the function given by fx equal to 1 plus x, 1 plus x square, 1 plus x to the power 4, 1 plus x to the power 8, and hence they have said to find the value of f dash 1. So fx they have given, it is what? 1 plus x, 1 plus x square, 1 plus x to the power 4, then 1 plus x to the power 8. Students, when you get this type of question, you have the so many options. One of the option is that you can differentiate directly u, v, w, x, w, z with that type of variable. One you will differentiate, remaining you will keep. In this way, 4 terms you have to differentiate. একটাকে ডিফারেন্সিয়েট করবে, বাকি তিনটা রাখবে, পরেরটা করবে, বাকি তিনটা রাখবে, এরকম করে করে করা যায়. Another thing, you can break this one, it is a big one. So many log also you can use. So here, if we use f dash x, then as I said, I will differentiate this and I will keep remaining as it is. 1 plus x square, 1 plus x to the power 4, 1 plus x to the power 8. As it is, I have kept. If we differentiate 1, it is 0. If we differentiate x, it is 1. So no need to do anything. Next, I will differentiate this and keep remaining. If we differentiate this one, 1 is 0. Differentiation of x square, it is what? Twice x. And remaining one is what? 1 plus x, 1 plus x to the power 4, 1 plus x to the power 8. We can do like that. Now, if we differentiate this, 1 to 0, x to the power 4, if we differentiate, it is 4x cube. Then we can keep remaining 1 as it is. Now last one, if we differentiate this, it will be what? 1 is 0, x to the power 8 is 8, x to the power 7. And you will keep remaining as it is. 1 plus x, 1 plus x square, 1 plus x to the power 4. So this is our f dash x. So here this technique you have to use, you know uv formula it is. So like that we can do. Then f dash 1 they have asked. Means what? All x you have to replace by 1. If we replace it is by 1, 1 square to 1, 1 plus 1, 2. There also if you put 1, it is 2, it is 2. here 2 x1, this and next term it will be 2, it will be 2, this will be 2. Why? Because x if you replace it is this. Here 4 x if you replace it is by 1, it is 1. This is 2, this is 2, this is 2. So 2 into 2 into 2. So you see the 2 2 comes. Then if we replace x here by 1, then this is 2, this is 2, this is 2. So this is our answer. So it is 8, this is 16, this is 32, it is 64. So after adding, I think result will be this gives 24, this gives what? 96. So it is 0, 120 is the answer. Now question number 17. Question number 17, they have said, they have given one term and you have to what? Do this by, okay, quickly I am going to do question number 17. So they said they have given one product x square minus 5x plus 8 into x cube plus 7x plus 9. I will take this y. They have asked this product, you have to do first one by using product rule. Taking this one u, this one b, you have to do. Second, they said expanding the product to a single polynomial. That is, after breaking this, you have to do. Third one, by taking logarithm. If you introduce log, then what will be the answer? I have shown all the procedure, but at present, I will show first one by product rule. Product rule, that is, if you differentiate with respect to x, then you see what it will be the answer. Answer it will be, you keep this one, x cube plus 7x plus 9, you will keep as it is. If we differentiate this, x square differentiation is twice x, 5x if you differentiate it is 5, this one is 0. That is b du dx plus, you keep this one, x square minus 5x plus 8 as it is. You have to differentiate this part. If you differentiate this part, it is thrice x square. And if you differentiate 7x, it is 7, 9 to 0. So this is dy dx. So I think you can do the other also, other similar way you can do. That is, if you break, then y will be what? It is a form. B, if you multiply, then it will be what? X to the power 5, then something will come. Then you differentiate, same value will come. If you use log, then also similar way. Log y, then log this plus log that similar answer will come. Now I will move to the last part, last sum of this exercise, then I will finish my class. Question number 18 I want to do. They said you prove this one. So how to prove? Question number 18. So I have done the one part of this question number 17. If you are failed to do, you ask me, I will show. So question number 18, they said we have to show that if you differentiate u v w, then say that du dx plus into dw will remain same, u dv dx, w will remain same, and u v dw dx. That you have to do. So it is simple way to do. No need to worry about this one. How to do this one? So that LHS if we take d dx, u v you consider 1, w will keep. then it will be what? W will remain dUV dx. Then UV will keep, dW will differentiate. Now again you will apply this Leibniz product rule here. It will be what? B du dx plus U dV dx. Then UV dW dx. If we withdraw this bracket, then you see that du dx dW plus U dV dx W plus UV dW dx. So we proved this one. So with that we end our exercise 5.5. I think next parametric form, then second order derivative, 2 exercises left, and last one, that is 5.48 we will not do because it is under reduced syllabus. So I expect all of you have understood all these things, and with that we end our today's class.